All right. Hey, y'all. What's up? All right. This is our final video for the year. Can you believe we finally made it? I totally didn't think some of us were going to make it, but we made it. Okay. All right. So today's video's got 3 parts. Okay. We're going to finish up the packet. So we have SOL 612, 13, and 14. And then we're done. Okay. So let's get crack-a-lacking. All right, so we're going to start with number 47 with 612. Okay, so complete the table. Okay, so we got the number of cookies to the total cost. So two cookies cost $4, four cost $8, 5 cookies cost 10. Okay, we can do one of two things. We can just figure out what am I multiplying here to get to here, then do the same thing to 8, or I could find the unit rate like what we talked about, and then just multiply that. Okay, but let's see if we can figure this out. Okay, so 2 cookies cost 4, so what am I multiplying by 2 to get to 4? By 2. What am I multiplying by 4 to get to 8? By 2. What am I multiplying by 5 to get to 10? Times 2. So if that were to work and that's to be true, I should be multiplied by 8 cookies, and that should cost 8 times 2 is $16. Like I said, we can even find the unit rate by choosing any of these. So I'm going to choose $4 for 2. That's going to equal for 1 cookie. So I'm dividing by 2. 4 divided by 2 is $2 for 1. Again, times 2. Okay. All right. 48. Shiloh is looking to buy new pencils. She visits 4 stores and records the prices of each pack of pencil. At which store is the price of one pencil the cheapest? Okay, so this is where we're going to find the unit rate. Okay, so what I'm going to do is we're going to kind of go on a itty-bitty field trip. Okay, because the easiest way what we're going to be able to do to find the unit rate is we just got to divide. Okay, we're just going to divide the price by how many pencils you get. And to do that, I'm just going to use a handy-dandy calculator. Okay, and to do that, I've got to find my handy-dandy calculator. Okay, so this is also a good point in time to say, hey, just letting all of you in 6th grade know, you'll be seeing me again because I'm actually moving up to 7th grade, and I'll actually be teaching 7th grade science next year. Okay, so yippee skippy for some of you. For some of you, that was like, great, not him again. Okay, all right. So now I have my handy dandy calculator because I finally found them. Forgot where I put them. Okay. All right, so I'm just going to take the cost, how much they cost, by how many the quantity I get. So I'm going to put in my calculator, $1.44, not 10, divided by 4, and each pencil costs 36 cents. Okay. Do the same thing again, so $1.74 divided by 6. Okay, so now we have, so each of these pencils cost 29 cents. Okay, so we're going to go $3.10 divided by 10. So each one costs 31 cents. Notice what I want you to notice is that all I did was just move the decimal. Okay, I just moved the decimal over here. Okay, so 31 cents. So far, Writing World looks like the cheapest, but here we go. We got one more, so $2.56 divided by 8, 32 cents. Okay, so I have 36 cents, 29 cents, 31, and 32 cents. We want to know which one is the cheapest. Writing World is the cheapest. Okay. If you want to write it down here, you can. but I'm just going to circle it. Okay. All right. So that is it for 612. 612 is that one unit where we kind of started it when we were started online. We're going to be able to fix that one, and you're actually going to see that a lot again next year in 7th grade. So when you go to Miss Fannin or Miss Woodleaf next year, they'll be able to help out, get us caught back up. Okay. All right, and 49, I forgot there was one more. Which of the following ratios is proportional? So is, okay, so 3 of them are going to be wrong. So 3 to 2. Okay. Now, what I probably should be able to notice, and what you should be able to notice very quickly, is the larger number is in my numerator. So it shouldn't turn out where I have a regular ratio like this or like this. Okay. So I could probably go ahead and rule out A and C, but I'm going to be safe on the safe side for right now. Okay, so I'm going to hop up here because we're not using mean, median, mode, and range. So I have the ratio of 3 to 2. Well, now if I'm finding other equivalent ratios, I can just use my equivalent ratio. So we're going to say times 2, times 3, times 4. So 3 times 2 is 6, 2 times 2 is 4, 6 to 4. 3 times 3 is 9, 2 times 3 is 6, 3 times 4 is 12, 2 times 4 is 8. Okay, again, notice the numerator is still larger than the denominator. So I can go ahead and rule out both of those. Now, both of these are proportional, but that would mean that ratio would need to be 2 to 3. Okay, and do I have an equivalent ratio? Yes, I do. 9 to 6. Okay. All right, moving on to 1350. Which of the following is an example of a constant? Okay, so a constant, we talked about that. That's the number that's going to be by itself. Okay, this is not a constant. This is a term, so each individual part, so it's not A. Y is a variable, number we don't know. Minus 3, that is a constant. That's a term by itself, so that one works. And this whole thing right here, that's an equation because I have an equal sign. So I know I have the answer C. And 51, circle all the variables. Okay, the variables are going to be the numbers that we don't know. And it's also going to be the ones that's represented by a letter. Okay, so X, Y, and H. Those are the numbers we don't know. Okay? Those are the numbers we don't know. Alrighty, moving right along. Alright, and lucky for some of you, sorry not to sneeze. Lucky for some of you, not so much, is we never really talked about the properties. Okay? So we don't have to worry about those. So 52 is out. 53 is out. Okay? All right, so here we go. 54, which equation is modeled? So we don't have to solve it. We don't have to solve it. We just have to write it. So the long rods is X. So I have 1, 2, so 2X. The colored in circles are negative, so -1, -2, -3, so -3. The not colored in circles are positives, positive 1, 2, 3, 4, 5, 6, 7. So which equation matches 2x minus 3 is equal to 7? This one right here. Okay, you just had to look right here at the key. And that was it. 55. Damon went to the store to buy bags of chips. Each bag of chips cost $3. If his total was $24, which equation can be used to model this situation, assuming X stands for the number of bags he bought? So we don't know how many bags. Okay? We know each bag was $3 a bag, and we know they equaled up to 24. So we have 3 times the amount if he bought X is equal to 24. So it would be this equation right here. We're not adding how many we bought to 3 to get to 24. We're not subtracting 24 minus $3 to get how many bags he bought. And we're not multiplying $3 times $24 to get how many bags he bought. Okay? All right, 56. Which of the following equations represents the verbal sentence the difference? Okay, key word. So we're going to subtract. Is the other key word because this is going to be equal. So it should equals 10. So I know D is out. Okay, so we're subtracting. Okay, so we're subtracting. So I also know C's not out because that's dividing. Okay, so now we're down to is it either x minus 6 or 6 minus x. We just have to read it from left to right. So a number x, the difference of a number x and 6, a number x and 6 is equal to 10. So I have A. 57, find the value of x. Okay, find the value of x. Okay, so I'll read that as x divided by 3 is equal to negative 8. X divided by 3. Okay, so if I'm going to divide, that means I need to do the opposite. So I'm going to multiply by 3. Multiply by 3. These go away. So I'm left with x. So I have a negative times a positive, so which means my answer is going to be negative 8 times 3 is 24. So negative 24 divided by 3 is negative 8. Okay. All right, so that is it for equations. The last one we got is with inequalities. Okay. All right, so which of the following graphs represents the following situation? Maggie has more than negative $2 in her bank account. Okay, keywords, more than. Okay, so we're not saying either more than or equal to, so it shouldn't have a closed circle. So I know A and C is out. Okay, if it's more than, that means it's greater than. So I know my answer is B. Okay. All right, last side, y'all, and we're done. Which number sentence represents all values of x? So I want you to look. So it's a closed circle. That circle is filled in, so I should have a equal to. So I know A and B is out. Okay, my graph is going to the left. So it should be less than, not greater than. So no, my answer is D. 60. Select all the following that are solutions to the given inequality. So which means I'm going to have to solve this inequality. Okay? So if I'm adding 4, I need to do the opposite. So I'm going to subtract 4. Subtract 4. These go away. I'm left with x is greater than negative 2 minus 4, or that's negative 2 plus negative 4, negative 6. So I want to know the numbers that are greater than negative 6. Now, we're not including negative 6 here, so that one goes away. Okay, so I want to know the numbers that are greater than negative 6. So that'd be negative 2, 0, positive 2, and positive 1. Negative 8 is less than negative 6. Okay. 61. Which of the following inequalities has a solution set represented by the following graph? Okay. Now, look where my variable is first. My variable is on the left, so I don't have to flip these signs. Okay. I don't have to flip the sign. Okay. So it's going to have a closed circle. So it's going to be going to the right. Now, here's what I want you to notice, though. My variable is on the left, so I don't have to flip the sign. I really don't have to solve every single one of these. There's only one that has a closed circle and is going to the right. Done. That's it. Okay? You don't really even have to solve it. You just have to look at the graph. The signs going to the right, going to the right. Going to the right was only these two. Closed circle, closed circle. And that's it. All right, last question, and we're done. Can you believe it? So which student did not solve and graph their inequality correctly? Okay, so we do need to go through each of them. Okay, so let's look at this first. Okay, all of my variables are on the left. Okay, all my variables are on the left. So I'm going to look at my signs. Look at my signs first. So greater than has a go into the right with an open circle. Okay. He started with adding 3, so we needed to do the opposite. Subtract 3, 4 minus 3 is 1. Okay. Less than or equal to, go into the left, close circle. Good. She started with subtracting 1, so we're going to do the opposite. So add 1. Good. Okay. Greater than or equal to. Okay, I've got my closed circle, but his graph is going to the left. Okay. His graph's going to the left. So automatically, before I even look at the other one, I've got a good suspicion about this one. It did start with subtract 2, so we need to do the opposite. So add 2, greater than or equal to 2. Okay. So his works out that he did it wrong. And last one. So less than sign, not equal to, so it should be closed circle, going to the left, good. She started with adding 2, so we're going to subtract 2. 2 minus 2 is 0, good. So who didn't solve theirs correctly? David didn't solve it. What was his mistake? He graphed it incorrectly. Okay? He graphed it incorrectly. All right, y'all. That's it. Okay? We're done. Okay? We are done. It's been a great year. It's been a long year. It's been a different year. But we finally made it. Okay? So what I want to do is I want to wish you all have a great summer. Go outside. I don't really care what the CDC says, but yeah, that's just me. Don't tell anybody else that said that. And enjoy it. Like I said, I'll see all of y'all again in 7th grade next year. The ones that'll be here at LMS. If you're not coming back to LMS, I want to miss you. I will. And have a great summer. And I'm out of here, y'all. Later.